Yes. Good. Right, right. I guess.
Taking the last question, so I was a little confused. I don't know if I think on like the math on like the period.
Mm-hmm.
And then on math.
Oh, thank you. So the period should have been the difference between the two x coordinates that you had. So the x coordinates on that one were 1/4 and a 1/12. So if you subtract the two, what did you get? A third? Yeah. So your period was a third, and you set that equal to the pi over b in that case for the tangent, because tangent's period is only pi. So your b must have been what, pi over 3, or sorry, 3 pi. You get a third. Does that make sense? Any other questions at all? Ready for the weekend? Always. All right. Well, let's continue on our discussion with some inverse trig functions and finish that stuff up today. So remember last time we came up with different properties for inverse sine, inverse cosine, inverse tangent. We didn't get any time to do any examples, which is okay, because we're going to do lots of examples today, as you can see by the number of examples that we have here in your packet and on the board. So we'll do lots of examples today with the inverse trig functions. The big thing to remember is that when you're asked to find the inverse trig function of a number, you're trying to find the angle that has that value as its sine or cosine or tangent, keeping in mind that you have to make sure it's in the correct restriction, right? So for example, in this first one, we're asked to find the inverse sine of root 3 over 2. So what you want to think in your mind is, what angle gives us a sine value of root 3 over 2? So what angle do you know?
45.
Yeah, it's a 60-degree angle, so it's pi over 3, right? So that's what we're looking for. Now again, there's lots of different angles that work, right? Pi over 3 works, 2 pi over 3 works, and then you could keep going around this in circles again, right? Add any multiple of 2 pi that you want. But remember, we restricted the sine function to be able to define the inverse sine function, right? So I remember, anything that comes out of the inverse sine has to be between negative pi over 2 and pi over 2. You get an angle either in quadrant 1 or in quadrant 4. So that's where you're looking for the angles in this case, okay? So in this case, this is going to be pi over 3. So again, remember, inverse functions undo whatever the original function did, right? So rather than putting in an angle and getting out a value, we're going in the reverse. We're going to put in a value and get out an angle that corresponds to that value. So let's look at the next one. The way I like to think about them is, first I ignore the negatives and then I figure out what I need, okay? So if I ignore the negative and I just had root 2 over 2, what angle has a sine equal to root 2 over 2? Yeah. Pi over 4, right? So this is going to be some flavor of pi over 4, right? Now again, since it's negative, am I looking in quadrant 1 or am I going to look in quadrant 4? 4, right? So what angle do you think we should use? Instead of using positive pi over 4, we should use negative pi over 4. Exactly right. Yep. Okay. So remember again, if we think, sometimes it's helpful to think about picture maybe. We need to be somewhere over on this. Oh, that was a really bad half of a circle. We need to be somewhere over here, right? All right, because up here is pi over 2. Here's negative pi over 2. We're looking for that pi over 4 angle down here. Yes?
So you wouldn't put 7 pi over 4?
We wouldn't put 7 pi over 4 because, again, it's because of the restriction of the inverse sine function. It specifically has to be that. So again, when we have a function, we put one thing in, we have to get one thing out. You're exactly right. Sine of 7 pi over 4 is negative root 2 over 2. Unfortunately, 7 pi over 4 doesn't fall on our restriction. Yeah. That one okay? Now that idea that you just mentioned is something we're going to come back to later when we start talking about solving trig functions and have to go find all of them. Yeah. So this only finds one of them, essentially. Is that right? Let's do the next one. Again, if we ignore the negative, what angle has a sine value equal to 1? Pi over 2, right? We want the negative one, so instead of using positive pi over 2, we'll use negative pi over 2. Yeah. Again, it has to be the negative pi over 2 due to our restriction, right? We restrict the values coming out of inverse sine to be between negative pi over 2 and pi over 2. 3 pi over 2 is another angle that has a sine value equal to negative 1, but that's not in our restriction. Does that make sense? Cool. All right. Pardon me. Let's look at the next row. All of the next row involve inverse cosine. Where do we restrict our cosine function in order to be able to define our inverse cosine? Where did we restrict to for cosine? Was it the same negative pi over 2 to pi over 2? It was 0 to pi, right? Remember, negative pi over 2 to pi over 2 didn't work because that was the cosine graph just looked like a bat on the interval, right? So it wasn't 1 to 1. So again, every angle that we get out of these has to be between 0 and pi, either in quadrant 1 or in quadrant 2. And specifically between 0 and pi. So looking at this first one, again, let's ignore the negative. What angle has a cosine value equal to 1/2? Pi over 3, right? Cosine of pi over 3 is 1/2. Okay. You know what they say? You have to know things backward and forward? Literally have to do this backward and forward, right? For the cosines and the inverse cosines and so forth. All right. So pi over 3 is an angle that has a cosine equal to 1/2, but this is negative 1/2. So rather than being in quadrant 1, we want to be in quadrant 2. So what angle instead should we be talking about? Is it negative? Well, the negative would be down in quadrant 4, right? And again, for inverse cosine, it has to be between 0 and pi. So nothing that comes out of inverse cosine will be negative. It'd be the 2 pi over 3, right? So again, if sometimes it's like the picture helps, maybe a reference angle would help. Reference triangle would help. So I know that pi over 3 is over here. If I want to match in quadrant 2, if this angle is pi over 3, then this whole thing must be 2 pi over 3, right? So we get 2 pi over 3 for that one. Okay. What about inverse cosine of 0? Well, it's a little bit different. Again, the way you want to think about it with these inverse trig functions are what angle has a cosine equal to 0? Yeah, 90 degrees of pi over 2, right? So we're doing everything in radians, yeah? Okay, so pi over 2 will be work here. Good. And that definitely has been between 0 and pi. In fact, it's halfway in between 0 and pi, right? Yeah. Now let's look at part F. What angle has a cosine value equal to 1? 0 does, right? So that one would be 0. 2 pi does, 4 pi does, all of those do. But again, we restricted to 0 to 2 pi. Or 0 to pi, I mean. So 0 would be the answer. So I'm going to do a couple more off to the side here before we do the tangents and keep going. So what if I asked you inverse sine of, if I done a half? You would tell me? Yeah, so yeah, we want to know what angle has a sine value equal to half, and that would be pi over 6, right? Or if I asked you inverse cosine of negative root 3 over 2. Yeah, let's do it with the 5 pi over 6. You're exactly right.
Well, the reference was pi over 6, and it's all in.
Good. That's exactly right. So again, if you think about reference angles, I ignore the negative. You want to think, what angle has a cosine equal to root 3 over 2? Pi over 6 works, right? But since it's negative, instead of being in quadrant 1, the angle needs to be in quadrant 2. But the reference angle is pi over 6. It's exactly the right way to think about it. At least in my mind, it's the right way to think about it. My reference angle is pi over 6. So that whole angle must be 5 pi over 6 because it has to make up the whole pi, right? Let's do another one. What about inverse sine of 0? Yeah. It's just 0 because why?
It's the inverse of like of 90 and the sine of 90 is 0. I mean the sine of 90 is pi over 2.
So the 0 is the right answer. So you're thinking, I think you're just off the wrong angle. So what angle has a sine value equal to 0 is 0, right? So that's why it was 0. Yeah. So, yep. Versus if I asked for inverse sine of 1, what would we get? That one would be pi over 2, yeah. Because again, sine of pi over 2 is equal to 1. Is okay? Yeah. Oh, so this one up here, I didn't finish right on the answer, did I? 5 pi over 6. All of them are in radians. All of them are angles. Every single one of them is an angle. They're all will be in radians. We'll do all of these in radians. Yep.
And then above you got 5 pi over 6, or you got 0.
Right. So 5 pi over 6 is the same thing as 150 degrees. The way I got that one was ignore the negative. Think about cosine of what gives you root 3 over 2. The what would be pi over 6, right? Because cosine of pi over 6 is root 3 over 2. Okay. But again, it's not in quadrant 1, it's in quadrant 2 because the value that we're trying to take the inverse cosine of is negative, and cosine is negative in quadrant 2. So using your pi over 6 as your reference angle, what's this piece? We know that all the way around to here is what? If I go from here to here, what is that? If I go halfway around the circle, that's going to be what? It's 180, which is the same thing as in radians. What's it the same thing as? Pi over 2 is 90. 2 pi is all the way around. Pi, there you go. Yeah, halfway around is pi. So this is taking up, the reference angle takes up pi over 6 of it. And that's where the 5 pi over 6 is coming from. If you subtract out the pi over 6 from pi, you'll get 5 pi over 6. So, like this one here, I want to know where, or you can think about it from the graph. There's another way, but I want to know where the sine, this is asking me what angle did I plug in if I got one out. That's what we're doing for the inverse, right? I'm given the output, I need to find the input I'm undoing. So what angle, when I take the sine of it, gives me 1? Well, that one's pi over 2. So I'm looking for the angle each time. Let's see if we can do a couple of these with a tangent. Hopefully it'll make more sense. Tangent, I think, is a little bit more difficult because usually we think about the tangent with the sines and the cosines. So we got to figure out what makes up those different pieces. But first, let's ask for a reminder. What quadrant are you looking for your angles in if you're doing inverse tangent? Sine was 1 and 4. Cosine was 1 and 2. Tangent is 1 and 4 again, right? Inverse sine and inverse tangent, their answers will be always between negative pi over 2 and pi over 2. Okay? Cosine is the one that's between 0 and pi. Cosine's got a weird one. All right, so let's look at this one. Again, I always like to ignore the negative first so that I can figure out what reference angle I'm talking about. Okay? So I want to know, when you take the tangent of what angle, what do you get? How do you get 1 out? It's going to be pi over 4. Think about it another way. If I think about sine and cosine, if the tangent's going to be 1, the sine and the cosine have to be what? Equal to each other, right? Where does that happen? Pi over 4. They're both root 2 over 2. Okay. So this one, pi over 4 would be the reference angle, but I need negative 1. So instead of in quadrant 1, we need to be down in quadrant 4. So instead of using positive pi over 4, we'll use negative pi over 4. Yeah. That okay? Does that make sense what I'm saying with that one? And again, I personally like to go back to sine and cosine with these. By the way, anything that I'm going to ask you for an exact value, you're going to go back to 0, pi over 6, pi over 4, pi over 3, pi over 2. It's going to be one of those angles or the corresponding one that's in the other quadrant, right? Those are the only ones we know the exact values of. So it has to be one of those 5 or any other quadrant of those 5, right? So looking at part H, am I going to be looking at what I'm taking the inverse tangent of? Am I looking for an angle in quadrant 1 or 4? 1, right? Because again, that value is positive that we're doing the inverse tangent of. So the tangent would have to be positive of the angle, right? So it has to be in quadrant 1. I think of this as the way I like to go back to sines and cosines personally, but if you know these values, that's great. But I like to think about the sines and cosines personally. I've got sine over cosine gives me tangent, right? I need to end up with root 3 on top, right? It's like root 3 over 1. So basically, I'm looking for when the sine has a root 3 in it. When does that happen? Pi over 3, yeah. So this must be pi over 3. Now you can check your answer that way, right? Sine of pi over 3 is root 3 over 2. Cosine of pi over 3 is a half. And I really do get root 3. Versus if I have root 3 over 3, that root 3 on top here, but I have a bigger number on bottom, don't I? So this would have happened by rationalizing at the root 3 on bottom. So instead of being positive root 3, this would be like a 1 over root 3. So that means my cosine would have to have the root 3 in it. When's cosine have a root 3 in it? Pi over 6, but since this value is negative, instead of using pi over 6, what will we use? Negative pi over 6, because it has to be in quadrant 4. That's okay? Takes a little bit getting used to, I know. You can always check your answers in your calculator, by the way, all right? Do inverse sine of the value, and even if it comes out with a decimal, type in this thing and see if you get the same decimal. If you get the same decimal, you did it right. As you're practicing, now on your exam, there will be a non-calculator part again. There'll be a few of these to do with non-calculators, but that's how you can check it right now as you're practicing. All right.
I have a question.
Yeah.
Like, can you do it the same way as, like, I guess doing it as using the identities like sine and cosine, breaking them apart, and then like
For the tangent ones?
yeah.
Yeah, that's kind of how I'm doing it. As I'm thinking of, I need to end up with a root 3 when I do my sine over my cosine, so the sine must have had the root 3 in it.
Right.
Yeah, that's how I think about it when I'm going backwards that way. You can also draw a triangle and see if you can recognize what kind of triangle you have. What I mean by that, and we're going to use triangles here in a minute. What I mean by that is, remember, this means this expression right here would mean tangent of theta equals root 3, right? If I get it, so if I start with theta equals inverse tangent of root 3, I take the tangent of both sides. That's what that means, right? So I would need to create a right triangle where my opposite side is root 3 and my adjacent side is 1. Pythagorean theorem would give me a 2 for my other side, and I should recognize that then as a 30, 60, 90 triangle. And so this would have to be a 60-degree angle there. That's another way to do it, create it out of the triangle. Personally, I think that takes a little longer, but you can do it that way. We will come back to this triangle idea here in a little bit when we're simplifying some expressions. All right. Pardon me. Any other questions before I go on? Okay. Notice that these next 6 parts all talk about composing a function and its inverse. Well, the whole point of discussing inverse functions is to undo what the original function did, right? It's the entire point. However, remember with trig functions, we have to restrict our domains, right? So that's what I'd say the more difficult part of simplifying this is making sure that we understand that we're in the correct restrictions when we try to simplify these things. Personally, what I think is a little bit easier with these in particular is just work through it a step at a time, rather than trying to simplify it all at once and worry about your restriction. You can do it that way, but I personally think it's a little bit easier just to do it a step at a time. So if I look at this first one, what is sine of 4 pi over 3 equal to? Well, the reference angle is what? And sine of pi over 3 is root 3 over 2. Is it a positive root 3 over 2 or a negative root 3 over 2? Because? Good, it's in the third quadrant, right? One pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3 is down there, right? So it has to be negative. So then when we now do the inverse sine of that, do we get back to 4 pi over 3 again? Is 4 pi over 3 in the restriction? What I mean by that is what values does the angle have to be in between for inverse sine? Negative pi over 2 to pi over 2. So this answer isn't 4 pi over 3. What is it instead? Negative pi over 3. Good. So again, it's all about the restriction idea. Okay? That's why I think on these it's just easier to go through a step at a time and just simplify it, personally. Okay, let's do the next one. Reference angle for negative pi over 6 is pi over 6. Cosine of pi over 6 is root 3 over 2. Negative pi over 6 is in quadrant 4, so the cosine is positive. Yeah, so it's root 3 over 2 is all we get. What do we get now when we do inverse cosine of root 3 over 2? What do we get? Yeah, just pi over 6. Good. It's positive pi over 6. That's exactly right. So again, I don't get back to where we started because why? Is negative pi over 6 in the restriction? No. The restriction for cosine was what? 0 to pi. Okay, so this cannot just simplify to negative pi over 6. Okay, it's not in the right restriction. Okay. Last one here, and maybe another way to think about it is, and I'll go back through the other two and think about it the same way. Maybe this is another way you might want to think about it. Where is 3 pi over 4? It's in the second quadrant. It's over here, right? Is that in the correct restriction for tangent? No. Can you fit? The restriction for tangent is over here. Over here is the tangent positive or negative? Negative, right? So what angle, or excuse me, which quadrant do I want to look for an angle if it's going to be negative? Down here, right? So what angle do we need to use instead? Instead of 3 pi over 4, this is going to simplify to what? Negative pi over 4. Exactly right. That's another way to think about it. If you don't like to think about it that way, don't. We can do the same thing we just did in the previous examples, right? Pi over 4 would be your reference angle. Tangent of pi over 4 is 1. 3 pi over 4 is in quadrant 2, so it's negative 1. And then when we do the inverse tangent of that to get to the right restriction, I got to be in quadrant 4, and it has to be pi over 4 for your reference angle to get the same answer. Like I mentioned, I could do the other two the same way as this one. What I mean by that is, let me redraw the picture and erase this one. Four pi over 3 is over here, right? And we're doing, eventually we're getting to inverse sine, correct? Down here is sine positive or negative? Negative, right? For inverse sine, I need to be in one of these two quadrants. Is it 1 or 4 if the sine is negative? 4. And I got to go this way. So what angle are we talking about? Negative pi over 3. Okay. For the cosine, negative pi over 6 is down here. Is cosine positive or negative down here? Positive. So inverse cosine is one of these two quadrants. Which one do we want if the cosine is positive? 1. So this angle must have been pi over 6 that we want. It's another way to think about it. You don't have to do it this way, but this is a more of a picture-oriented. If you like the pictures, that's more picture-oriented. So maybe I'll do another one with a picture. What have I asked you for inverse sine of how about 11 pi over 6? First off, is it just 11 pi over 6? Can I just cancel out the sine and the inverse sine? What I'm asking is 11 pi over 6 in our restriction? No. So the answer is not 11 pi over 6. Okay? But it's some flavor of pi over 6. We just got to figure out which flavor. Maybe it's Rocky Road, maybe it's Neapolitan, I don't know. But I got to figure out which flavor of pi over 6 it is, right? Okay? So again, if I go for the picture idea, what quadrant is 11 pi over 6 in? 4, right? All the way around to here would be 12 pi over 6, 2 pi. So it must be just short. So your 11 pi over 6 is in quadrant 4, right? Right? In quadrant 4, sine is negative. Instead of measuring this way, though, we want to measure this way for the inverse sine. So what's this going to simplify to instead? Negative pi over 6. Good. So you can either, if you like more of a numerical approach, you can simplify inside out and think of it that way. If you like a more picture approach, you can do it this way. Either or. Whatever you're comfortable with is the right way to do it. Okay? You want to do one more like that? Yeah. What if you were asked for inverse cosine, pardon me, of cosine of, let's say, 13 pi over 4? Again, first question, is it just 13 pi over 4? Is 13 pi over 4 in the restriction? No. Okay. So, but it must be some flavor of pi over 4, right? Because a pi over 4 is the reference angle. Okay? All right. Where does 13 pi over 4 end up? Well, all the way around is how many pi over 4s? 8, right? And then the other half gets me to 12. So 13 pi over 4 must be over here. Right? Now I need to figure out where the angle is that I really need for inverse cosine, right? Over here, this is in quadrant 3. Is cosine positive or negative here? Negative. Inverse cosine gives you an angle in quadrant 1 or 2. So I'm looking up here, right? So what angle over here do we need instead? What angle is this one that we need? 3 pi over 4. Good. Does that make sense? Does the picture help? Would you rather just not do any of it and say screw it? Not that that's an option. I'm just asking you if that's what you'd rather do. All right. Let's look at these last ones and then we'll move on to some other types of problems because you all look exceptionally bored. Bored, confused, hate me, I don't know, one of those emotions. All right, anyway, this is the other way around, right? Now we're doing the composition of the inverse functions, but the other way around, right? We're first doing the inverse and then doing the trig function. Okay? This one's basically a question of, am I allowed to plug the number into the inverse function to start with? Okay? Am I allowed to put in 0.6 into inverse sine? Remember, inverse sine is the domain of the inverse sine is the range of sine. Sine is in between. For range, the range of sine is -1 to 1. Is that number between -1 and 1? Yes. Are we allowed to plug it in then? Yes. So what's the answer going to be? It's just be 0.6. Good. That's the whole point of inverses, right? They're supposed to undo each other. We just need to make sure we're in the right spot. So what about the next one, though? Am I allowed to plug in -2.3 into cosine or inverse cosine? No. Because again, remember what this is actually asking you. It's asking you what angle has a cosine equal to -2.3. No such angle exists, right? So what would I say for this one then? Do you think? Undefined. Yep, exactly right. I'm not allowed to do this, so it just must be undefined. Actually, the interesting part is For our purposes, it's undefined. But if you introduce complex numbers, you're actually allowed to do that. It's not something we're going to do. You don't have to worry about it. Undefined is a perfectly acceptable answer here. But notice the difference. This one's okay because 0.6 was between -1 and 1. This one's not okay because -2.3 is not between -1 and 1. That make sense? Okay. Over here, same idea. Remember, domain of inverse tangent is the same as the range of tangent. What's your range of tangent? All real numbers. So the domain of inverse tangent is all real numbers. So is there any issue with that expression in that last part? Nope. So what answer are you going to get? 59.2. Yeah, they just undo each other in that case. Okay. Again, the whole point of these exercises isn't because these are so much fun that I love to do them over and over again. The whole point of doing inverse functions is so that we can solve equations later. We have to consider these things later, especially when we want to find non-exact answers, doing things with our calculators. Your calculator is only going to give you one inverse sine or one inverse cosine. But there are going to be multiple solutions to equations. We have to know how to find the other ones. Okay? That's why we're spending so much time on these. All right. Let's go back. I said we're going to do some triangle things. We're going to do some triangle things. That's what these problems are. These are triangle things. These are a little bit more fun, I think. We don't have to think so hard. Okay. All right. The way I like to think about it, when you're doing inverse trig functions, again, you plug in a value, get out of angle, right? So our default letter to denote an angle is theta. So start there. Now let's rewrite this equation without an inverse function. How do we rewrite this equation without the inverse function? How do we rewrite it so it's an equivalent statement but doesn't say anything about inverse? It's not quite multiply, but you get the right idea. Yeah, it's take the sine of both sides, right? So that says sine of theta has to be -4/7. Okay. Now, let's draw, this is exactly like the types of problems we've already done, by the way. Let's draw a triangle. I just have to know what quadrant to draw my triangle in. Theta came out of the inverse sine. Inverse sine gives you an angle in which two quadrants? Inverse sine, the angle comes out is in which two quadrants? Either 1 and 4, right? Where do you think I want to draw my triangle then? Given the fact that it's -4. Yeah, exactly right. Let's draw our triangle in quadrant 4. Tell me what sides to label.
The opposite would be 4. Or, 4.
Yeah, before, and I'll make it negative since it's below the axis, right? And then hypotenuse is 7, right? Can you figure out the adjacent side? Hope so. What is that? Square root of 33? 49 minus 16 is 33. Take the square root. Pythagorean theorem, right? What did I call this thing right here that I'm putting a little brace under? What did I call that? Over to the right. What did I call that whole expression? Not a trick question. What did I call it? It's written right to the right. It's written right there. Theta. Yeah, it wasn't a trick question. I called that theta. So this is asking you for just cosine of an angle. And I have the reference triangle. Can you figure out the cosine of theta from that reference triangle? What is it? 33/7, yeah. Does this type of problem look familiar? I give you the sine of an angle and you figure out the cosine of the angle? Does that look like a problem we've done? I think so. Yeah. All right. Let's look at the next one. Do the same idea. Let's say theta equals inverse cosine of, good grief, 9 over 13. First thing to do, I would do, is rewrite the equation so that it looks like a problem we've already done. How would I rewrite that equation? Good. Cosine of theta is 9 over 13. Inverse cosine gives you an angle in which two quadrants? Either quadrant 1 or 2. Good. Am I going to draw my reference triangle in quadrant 1 or quadrant 2? 1, because it is positive, yeah. Here's my reference triangle. What sides can we label? Adjacent and hypotenuse. Adjacent is 9. Hypotenuse is 13. Can we figure out the opposite leg? Yeah. Pythagorean theorem again, right? Oh, well, 169 minus 81 is 88. So it'd be square root of 88. I want to be fancy. What is that? That's 2 root 22. I don't care if you're fancy. You can leave it as square root of 88. We want, again, what did we call this?
Theta.
Theta. So the problem is asking you for cotangent of theta. How do you find cotangent? What do you use? Yeah, 1 over tangent. Tangent is opposite over adjacent, so cotangent is the adjacent over the opposite, so this will be 9 over 2 root 22. And again, if you want to be fancy, you could rationalize. I do not care. Could not care any less about being fancy. I mean, look how I dress. You really think I care about being fancy? Is okay? Remember I mentioned this last time. When I say arctan, that means the same thing as inverse tangent, right? So same idea here. Make that theta. So rewrite the equation. Tangent of theta is equal to negative 15 over 8. The big thing about these is remembering where to draw your reference triangle. Inverse tangent gives you an angle in fourth quadrant or first quadrant, right? Why is it the fourth? You're exactly right. Because it's negative, right? It's negative 15 over 8. So it must be in quadrant 4. So my reference triangle goes down here. What do we label? The opposite is negative 15. So the adjacent is 8. Hypotenuse will be 17. And we want secant of the theta, right? So what's the value going to be?
17 over 8.
Good, 17 over 8. Good, 1 over the cosine. These are the exact same types of problems we did before, aren't they? I mean, literally, they are the same problem. They're just written differently. But they're literally the same problem. So are the next ones. They just have letters instead of numbers. We're going to do these the exact same way, and these are even easier because I don't have to worry about a reference angle or a reference triangle. I'm just going to draw a triangle, okay? Don't even have to worry about whether it's positive or negative or what quadrant. These, what we're doing now, algebraic expression, we're literally just going to draw a triangle to help us, okay? So you don't even have to worry about quadrants for these without when it doesn't have any numbers, all right? Same exact concept. Theta equals inverse sine of x. Rewrite it. Sine of theta equals x, right? I'm not even going to draw axes. I'm literally going to draw a triangle. I want to make my sides of my triangle so that the sine of theta is x. What sides can we label if we have sine? Opposite and hypotenuse, right? So what do you think you should make the opposite? And what do you think we should make the hypotenuse in order to get x when we're done? X and 1. Yeah, opposite is x. Hypotenuse is 1. Can you figure out the adjacent side now in terms of x? Pythagorean theorem again, right? I take my hypotenuse squared, subtract your opposite side squared, take the square root. Again, we're not going to worry about negatives or where it is. We're going to make everything positive. So it'll be square root of 1 minus x squared. We don't need to worry about if it's negative or not. Okay? We okay with how I got that triangle? Okay. Notice this is what I call theta again, right? I want tangent of theta. What gives you tangent of theta? Yeah, opposite over adjacent, right? The opposite is x. Adjacent is root 1 minus x squared. There you go. This is what we mean by an algebraic expression. You get an algebraic expression in x if all you use is addition, subtraction, multiplication, division, and roots. That's an algebraic expression. No trig functions, no exponential functions, no log functions. Algebraic is any of the algebraic options you can do. Yeah, operation.
So this is like the format minus for the other questions we did. So like, but they just had a value for x.
Yeah, yeah, exactly right. This is exactly like the previous problems. We just, like I said, we just don't have to worry about where the reference triangle is. We're going to use everything's going to be positive. Yeah.
So like, yeah, I mean, if you were to like, I just rewrite this question, but with value for x, could you just like plug that value where x is?
Yep. As long as the x is between -1 and 1 in this case, yeah. And you can also see that down here, right? Because if it's not between -1 and 1, you'll take the square root of a negative number. Yeah. All right, so first step, what should I do in this next one? Yep, so theta equals inverse tangent of 7 over x. So tangent of theta must be equal to what? 7 over x. Next step is to get a triangle. What can we label?
Opposite 7 adjacent is x.
Good. Opposite is 7, adjacent is x. Can we figure out the hypotenuse from that information? 7 squared plus x squared is hypotenuse squared. So take the square root, you'll get x squared plus 49. That okay? And now what do we want out of this? Secant of theta, right? This is the thing that we called theta. We want the secant of that. What is the secant of that?
X over root x squared plus 49. The other way.
Yeah.
Yeah.
Yep. Yeah, you did cosine, right? So we need to do hypotenuse over adjacent. So it would be square root of x squared plus 49 over x. And again, this is why I calls it an algebraic expression. Because again, all we have is addition, subtraction, multiplication, division, or roots. And in particular, the only root you'll see in a lot of these is just the square root. That's what it means by an algebraic operation. We're getting rid of the trig functions. This okay? All right. I'll leave the last one for you for practice. We will do those last couple of applications problems on Monday, as well as get into the next section. Everything that we've done so far has been right triangle trig, but is every triangle a right triangle? No. So we're going to talk about how we solve triangles when we don't have a right angle in there. So we'll start talking about that on Monday. Have a good one. We'll see you then.